All right, so now now that we know what a vector is and how we can write it in the x component and the y component, let's look to see how we can do some operations on it, like addition and subtraction. All right, so what I'm going to actually show you is called the parallelogram method. So let's see if I can spell it right. Parallelogram, not spelled right. Parallelogram method. Essentially, we're going to set up parallelograms and what vector, and I'll explain in a second. All right, let's say I have a vector of 10, comma 2, and I have a vector of, and I want to add it to vector 2, comma 2. Well, the parallelogram method, I want to be honest with you, I use it to set up problems so I can see what's going on, but I never actually do this to add vectors. I add vectors either, I add it like just mathematically, analytically. But I use it to help set problems up so I understand what's going on. So let me at least show you what's actually going on here. So if I have on the xy plane a vector 10, 2, well, I'm going to assume I'm going to start at 0, 0, and I'm going to graph 10, 2. Let's call this 10, 2. And I'm going to come from the origin out. So that's 10, 2. And then I have another vector at 2, 2. So we're going to start at 0 and we're going to come up to 2, 2. So it's going to be on the same line here. Let's call this 2, 2 right here. Why not? And we're going that direction. And we want to add these vectors. Well, what the parallelogram method tells us, or what we really do know, is that this has a direction and magnitude. There's actually an infinite amount of different vectors, location, that's going to have the direction and magnitude of 2, 2. So there's another vector over here that has a 2, 2, making these two vectors parallel, two sides of a parallelogram. Well, this vector 10, 2, there's also another vector up here that's going to be parallel to it, making a parallelogram. The resultant force, and the resultant force is when we're going to add these together. So this right here, when we add them, is I'm going to come from the origin, and it's going to be the diagonals, what I'm actually looking for. So if I knew that point right there, because this right here is 0, 0, if I knew this point, I know the vector. Well, I do, because if this is 10, 2, right, this point's going to be 10, 2 because it's 0, 0. Well, this point, well, I'm going to go over 2 more because I went over 2 more, and I went up 2. So this point is going to be 12, 4. Well, then I have a 0, 0 and a 12, 4. This gives me, let's see, tip minus tail is going to give me 12, comma 4. So the parallelogram method is not really a way that you're going to add them up, to be honest with you, because you'd have to use the protractor postulate from geometry and the ruler postulate. And this is only if you're given a geometric vector with no way of actually calculating what the distance is. Then you use a ruler and a protractor, you set up a parallelogram, draw the diagonal, and voila, you would have the actual answer. That's kind of a forced way to actually ask this question. The parallelogram method, what I found to be more beneficial, is actually when you set up real life problems and you have like two vectors right here and you need to figure out what's actually going on. Then you draw a parallelogram by moving this vector over. It's really used more for the setup than it is for actually calculating. Say we wanted to subtract though. You can still use the parallelogram method to subtract. Say we wanted to do 10, comma 2 minus, let's see, 2, comma 2. It's just this other diagonal coming right here. Well, we know the change in my y direction is 0, and then the change in my x direction is going to be 8. So that vector would be 8, 0. But I actually did that analytically. I didn't even really use the parallelogram method to go. But this is 2, 2 right here. You could do tip minus tail and go from there. So voila, pretty straightforward. Actually, it goes the other way. Like that. And voila, easy peasy. So parallelogram method, really just need to know how to set it up for real life problems. Hi, I'm Mr. Buzzer, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click
the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.